All right, everybody, welcome back. Today what we're going to do is we are going to go ahead and do some synthetic division. So it's a special kind of division that we can actually only do when this value here, what we are dividing by, is a linear binomial. All right, and it's the properties of dividing by a linear binomial that make this possible. So we can only do it when this is a binomial, so two terms, and our variable that we are dividing by is to the first power. Okay, so what we're going to do is we are going to take what we are dividing by and set it equal to 0. When you do that, we are going to subtract the 9 over, and we get k is equal to -9. All right, so we're going to do our synthetic division with our -9. So you take the -9, and we're going to put it on the outside, and then we're going to use what looks like the bottom left portion of a rectangle. All right, and then take all of the coefficients, the values, the numbers in front of each of our variables inside what we are dividing. So the first one is 1, right? 1 times k to the second. Then we have a 13 times k, and then a 30 times k to the 0. That's our constant. How this process works is we are going to drop the 1 all the way down. Then we are going to multiply -9 and our 1 to give us a -9. On the inside of this, we are going to add. So I'm going to add 13 and -9 together to give us positive 4. Again, the 4 is on the outside, so now we're going to multiply. -9 times 4 is what we're going to do next, and that gives us 36, and it is negative. And once again, we are going to add on the inside going down. So 30 plus a -36 is a -6. How this works is our last value here is always going to be our remainder when we do division, the part that is left over when we do the division. So our answer here is we have our remainder. So it's -6 over k plus 9, because it's a value we still would need to divide. Then our 4 is going to be our 4 times k to the 0 power, or just 4. And then this will be the coefficient for k to the first. And I'm going to add in between here. So if there was other numbers in front, the number here would become the coefficient for k to the second. The number in front of that would be k to the third, k to the fourth, with the number in front. And that's how all this would work. These are all of the coefficients that we would get when we do division. Now, I obviously don't need these now because there aren't numbers in front. And what this tells us is when I get k squared plus 13k plus 30 divided by k plus 9, my answer is going to be 1k, which you could just write as k, plus 4, with a remainder of -6 divided by k plus 9. This here is our final answer. And it kind of makes sense if you think about it, because k times k should give us our k squared. The fact that there's a remainder here tells us that this does not go in evenly, so therefore we are done. All right, so it's pretty similar. It's pretty simple. It's basically what we're going to be doing for all of these. But again, you can only do our division here when what we are dividing by is a binomial to the first power. So this case is a little bit different because we have x to the third plus 3x squared minus 5. If you notice, there is no x to the first power. So really we got to remember that is a 0x to the first. That's in there, but obviously we don't have to write. Our synthetic division is going to work the same way. I'm going to take x plus 3 and set it equal to 0. When we solve for x, we get x equals -3. So the -3 is going to go on the outside. We have our synthetic division line here. And again, I'm going to take the coefficients. So the first number is the value, the coefficient to x to the third, which is just 1. Then I have my coefficient to x squared, which is 3. And now this is a very important part that a lot of people forget. I need to put the coefficient for x to the first power, which is 0. We need a placeholder, just like we have placeholders in numerical values. We need a placeholder when we are doing polynomial division. So whether it's synthetic or long division, either way, we need that placeholder value. And then I'm going to finish with our -5. So the process is going to remain the same. We drop the first number all the way down, and then we are going to multiply on the outside. -3 times 1 gives us a -3. And on the inside, I'm going to add going down. 3 plus a -3 gives us 0. And again, multiply. -3 and 0 is 0. We add going down to get 0. -3 times 0 is 0. And then again, add going down to leave us with -5. As we talked about before, our last value, our rightmost value, is going to be our remainder. So we have -5 divided by x plus 3. That's our remainder. This is going to be a 0, x to the 0 power, our constant term. This will be a 0x to the first, and then we have a 1x to the second. So I don't really need those values that have coefficients of 0. So my actual answer when I do x to the third plus 3x squared minus 5 divided by x plus 3 is going to be x to the second with a remainder of -5 over x plus 3. Now, some people don't put the plus here and they just put the minus up top down there. Either one is the same. When you're adding a negative, it's still subtraction, so that is totally fine. And this is our answer. Again, we can kind of check a little bit. This should make sense because we're taking something to the third power and dividing it by something to the first, which leaves us with something to the second power. All right, so for our last example, it's going to look a little bit different, looks a little bit more complicated. We have 8v to the fourth plus 6v to the third plus 12v squared plus 10v minus 1. So there's a lot more terms because we are dealing with a quartic polynomial, something to the fourth power, and we are now dividing by 2v plus 1. So our binomial that we are dividing by here is a little bit more complicated because there is a coefficient other than 1 here, but much of the process of what we did is going to be exactly the same. So I am going to take 2v plus 1 and set it equal to 0. I'm going to subtract 1 over so I can solve for v. I get 2v equals -1, divide by 2 to get v equals -1/2. So now this is the value that I am going to do my division with. We're going to have to talk about this dividing by 2 a little bit later on, so we'll come back into play a little bit. So I'm going to put my -1/2 here, and then I'm going to list out all of the coefficients of what we're dividing by. So we have 8 for the 8v to the fourth, then 6, then 12, then 10, and then -1. So the process remains the same. I'm going to drop the 8 all the way down, and then I'm going to multiply -1/2 and 8 to give me a -4, and we add going down. So I'll get a 2, multiply on the outside once again, and we will get -1, add going down to get 11. So here's where it gets a little bit more complicated because we are multiplying a fraction by an odd number, and particularly that fraction is 1/2. So that means we're going to start dealing with decimals, but that's okay. The process should remain exactly the same. I'm going to multiply out -12 and 11 to get -5.5. We add going down to get 4.5. And then again, -1/2 and 4.5 gives me a -2.25. One last time, we're going to add going down. -1 and -2.25 is a -3.25. All right, so here is where that division is going to come back into play that we talked about earlier. Because there is a coefficient of what we are dividing by, and it was 2, we had to divide by 2 to get the value that would go outside our synthetic division. So that means this right here is going to need to be divided by 2. So my actual answer is going to be 4, 1. Could leave this as 11 over 2, but I'm going to write 5.5. We get 2.25. And then this is going to be a negative, let's say, make sure I do the right value here. 3.25 divided by 2 leaves us with 1.625. So again, a kind of a gross number, but that process still remains the same except for this extra detail. So we divided those coefficients by 2. So our answer here is going to be 1.625 divided by 2v plus 1. That's our remainder. And then we will have our x to the 0 power, or our constant, 2.25. And again, that is negative, so I'll put a negative there and put a plus in between. And then I have a 5.5x to the first, a 1x to the second, and then a 4x to the third. So this right here is my final example. Again, it's a little bit difficult to deal with because we are dealing with decimals and we have to remember this extra step right here of dividing by 2. But majority of the process was the same, so it really wasn't that different for us. So when we have 8v to the fourth plus 6v to the third plus 12v squared plus 10v minus 1 divided by 2v plus 1, we end up with 4x to the third plus 1x squared plus 5.5x plus 2.25 plus a negative 1.625 divided by 2v plus 1. All right, so that is our last example. There is synthetic division for you. If you have any questions or concerns, please feel to reach out. Feel free to leave a comment. And as always, if you like the video, like and subscribe. All right, thank you for listening and have a great rest of your day.